So the aim of our research is enhancing LSA method with Ukrainian language support. The aim of our research is to increase the possibilities of semantic analysis of Ukrainian language texts due to the models of knowledge about the grammar of the Ukrainian language and about the subject area of the text, as well as by improving the semantic models of the processed text. So, the main tasks of our study are analysis of modern methods and means of semantic analysis of text, review of existing resources for processing and analysis of Ukrainian language text, development of the LSA method with support for processing Ukrainian language text, review and selection of technologies for the implementation of methods and tools, software development, research of the effectiveness of the development methods and software. So the main methods of semantic modeling are vector space model, VSM, latent semantic analysis, probabilistic latent semantic analysis, and LDA. Well, vector space model. This model is used to solve many problems of rapid analysis of documents, as well as to compile tables of search, classification, and clustering, and serves as a basis for many other algorithms. In this model, the document is considered as an unregulated set of terms, words, and additional elements that make up the text. Terms can be both words and their combinations, so called n-grams documents, ideally sets of thematically homogeneous text, or just and three-dimensional text, arbitrarily divided into pieces such as paragraphs. First of all documents are preprocessed. First of all, it is the removal of all punctuations, marks, and special characters. Also, it is necessary to exclude the so-called stop words or noise words. These are words that do not carry a semantic load, so their usefulness and role in the search is not significant. For example, all prepositions, adjectives, suffixes, exclamations, numbers must be excluded. A list of noise words for the Ukrainian language can be found in the repository of Ukrainian Search Engine Analyzer, Lucens. Latent semantic analysis. The model of text representation used in latent semantic analysis is in many ways similar to human perception of the text. For example, you can use this method to evaluate a text for a given topic or to review it. LSA displays documents and individual words in the so-called semantic space, in which all subsequent comparisons are made. The following assumptions are made. A document is just a set of words, and their order in the documents is ignored. It is important only how many times the word occurs in the document. The semantic meaning of the document is determined by a set of words that go together. Each word has a single meaning, which is simplification, but it allows you to solve many problems. Probabilistic latent semantic analysis is a statistical method for analyzing the correlations of two types of data. In general, this method is a development of latent semantic analysis, but unlike its predecessor, which was essentially an algorithm for constructing a vector representation with subsequent reduction of its dimension. Probabilistic latent semantic analysis based on mixed decomposition and use of probabilistic model, which allows better and more clearly identify possible topics of documents. But probabilistic latent semantic analysis in turn uses the probabilistic method instead of SVD. The basic idea is to find a plausible model with hidden terms that can generate the data observed in our term document matrix. Enhanced LSA method with Ukrainian language support. A corpus of Ukrainian language text is submitted to the input of the model, each of which must have a title and content to be analyzed. The body should contain a sufficient number of documents on various topics so that the model can highlight several different topics. The case should not contain duplicate documents. It is also necessary to pass two limiting parameters. The first parameter is the maximum number of topics that need to be output because the model will not be able to determine whether it is accurate enough to distribute the case on a certain number of topics. The user must set the upper limit. This does not mean that the model will identify as many topics as defined in the constraint, as some topics may include others. The second is the maximum number of words that should contain all topics in general. This parameter is necessary to visualize the result in the form of a graph because two complex structures can be difficult to perceive. At the exit of the model, we get a number of topics that were selected from the body of text. Each topic is a set of terms that are sorted by relevance to that topic in descending order. To perform calculations in our study, the method of latent semantic analysis was chosen, which is supplemented by our work, which provides support for the processing of Ukrainian language texts. The possibilities of semantic analysis of the method were increased due to the use of the NER model, named object recognition. Technology involves searching for and classifying objects in the text by a predefined category, including people names, organization names, locations, time parameters, quantities, monetary equivalents, and so on. The developed grammar-based system provides better accuracy and speed and uses a free open source library which has greatly simplified advanced natural language processing using the Python programming language. The main advantages of this method can be considered the high quality of definition of existing topics, if the body of text is large enough, as well as the ability to find non-obvious semantic relationships between words. The disadvantage of this algorithm is the high computational complexity and low speed, which requires a recalculation of all metrics for the entire body in the case of adding a new document. However, by optimizing the preservation of calculations, you can significantly increase the speed of the system. So this disadvantage should not interfere with its operation. Also, the method has higher requirements for the body of text, which consists of many different documents on the subject. So, the input data is a corpus of Ukrainian language text consisting of 4 short documents that contain common words to clearly show the results. After bringing all the words to the normal form, the part of speech of this term is determined using the Peremohy tool morpho analyzer. As a matrix A used TF-IDF matrix, the matrix I containing only k. The first linearly independent components reflect the basic structure of the various dependencies present in the original matrix. So this is a screenshot from the work of our developed software. With the full work of our software, you can see with a link provided in our paper in the reference list. Node.js technology and JavaScript programming language were used to develop the software that implements the method. The program code is available at the link. During the debugging of the system, it is loaded with a set of corpora of texts on various topics. The main panel of the system interface allows the user to configure the input data for the model. On it, the user, by means of the drop-down list, can choose the case of text or the necessary subject for carrying out the analysis. Also, this panel contains two sliders with which the user can set limits on the number of topics and the number of terms that will be displayed as a result of the analysis in the system interface. By default, the first case loaded into the system is selected. The slide limit on the number of terms is set on the maximum value, 50 terms, and the limit on the number of topics, 40% of the number of documents. In this case, the most important part of the graphical interface is the graph of terms obtained as a result of semantic analysis of the corpus of language texts. Notes in this column are terms, and edges are an indicator of the presence of two terms in one document. So, to study the efficiency of the model, it was decided to measure the speed taking in account the number of documents. In the case, this technique was chosen because the disadvantage of the method of latent semantic analysis is the high computational complexity and low speed, which requires recalculation of all values for the whole body. Which requires for the whole body in the case of adding a new document. Thanks to the proposed optimization of saving calculations, the speed of the system has significantly increased. The diagram shows a graph of the dependence of the speed of the model on the number of documents in the body of plain text. Speed is measured in seconds. The blue line shows the performance of the model with computational caching enabled, and the red curve shows no caching. For a case containing only two documents, the speed of the model without the cache is 264 milliseconds, compared to the speed of the model with the cache 34 milliseconds. If you choose a case that stores 30 documents, the speed of the model without a cache is 345 milliseconds, compared to the speed of the model with a cache 1824 milliseconds. Thus, we can conclude that due to the improvement of the method, it was possible to increase the speed of the system by about 6 times. And coming to the conclusions, We developed an improved method of semantic analysis of language text, developed model and visual interface to display the results of the system. The analysis of efficiency of work of system is carried out, and the prospects for further research include increasing the efficiency of the analysis of large buildings due to the distributed processing of input data. And thank you for attention.